Yes, so today we'll start with the next topic that is there in this particular module, which is about the advanced manufacturing systems. So what we have seen in the previous class is about the machining operations, especially about on lathe machine, milling machine, and drilling machine. And now with that, as the days are being progressing, technology is being improving, there is a need for automation and robotics. So we shall have a little bit introduction and details about the how is these automatic machines going to work, what is required, and a concept of all the robotics, right? Okay. So let us today see about the automation. Okay, and especially in that we have is the automatic machines, right? So these first thing is that when we started to have machines which are controlled by computer systems, as we all know, for a computer system, a set of instructions has to be given, right? Based on which the computer is going to process and suitable output is going to be received. So in these cases, when it comes to machining operations, we have to give the instructions to the machines such a way that it is going to follow that particular command and execute the operation, right? So it has to convert our programming language into the physical work it has to carry out, right? The physical work it has to carry out, right? So now in this case, okay, so the first thing is about, it is called as numerical control or only NC machines. Okay, that means these machines are programmable, okay, by making use of numbers, letters, and symbols. That is a set of instructions is being done, okay, and this program is fed to the machine for the machine to carry out the work, okay. That is onto the workpiece material to remove the material, machine it as per the instructions, right? So for this, a set of instructions has to be given as the input to the computer, which is going to control the machine. It can be a lathe machine, or it can be a milling machine, or any other machine. Okay, right. So in this, the basic things for this that is required for an NC system is the program instructions, right? And then this program instructions has to be received by the system. It has to process, have to give the required output, which is done by the control unit. And then the output from the control unit has to be sent to the machine tool, or whichever the machine it is. It can be a lathe machine or milling machine or any other machine, right? Okay. So here it has to take care of these things over here. So these are the basic components of a CNC system. So just a general representative of this. So a set of programming instructions to be fed to the controller unit, and the output from the controller unit is going to be fed to the machine tool, which is being controlled by electromechanical devices like motors, stepper motors, and other amplifiers, sensors, and so many other things, right? Okay, now coming to the program instructions, a detailed step-by-step program has to be written. Okay, just like how we generally study like C programming and Java, C++, and so on. But something similar to that, there is a set of there are many commercially available softwares on which a set of codes has to be written, which is called as G codes and M codes. Okay, which is understandable by the machine. So we have got a set of instructions, say for example G00, right? That means for this particular code, when we use it, is the meaning is that the tool has to move from the starting point to the ending point at the rapid speed. Okay, if we give G01, then the tool has to move from linearly from this particular point to the ending point. So along with this G01, we will also give what is the X, Y, and Z coordinates, right? So, and what is the speed? So the machine is going to, as soon as it sees G01, when it is going to read that particular line, and in that line there is G01, X15, Z minus 30, and so on instructions. Okay, then the tool is going to travel linearly until it reaches that particular point. Okay, that particular coordinate. So like that, a set of instructions will be written for every operation. Just as if you take up a lathe machine, we have seen facing operation, then turning operation, and all those things. So in facing operation, the tool has to move perpendicular to the axis of the workpiece, and it has to move from the outer diameter to the center of the workpiece linearly at a required speed. Okay, so like this, for this, every step by step the instruction has to be written. So that is what is going to be given in the form of program instructions over here. So that is going to make use of numericals, some symbols, alphabets, and so on. So in the older days, what they used to do was that there used to be, before coming with this set of instructions, there was a tape, okay, which used to have 8 columns, and in each one of that, some kind of punch will be made, like a hole will be made. It can be circular, it can be square. Sometimes there is no punch, okay, nothing is made, right? So like that, line by line, okay, line by line, these things were done. So each one of them will carry one set of instruction. So this tape will be fed to the reader, which will be attached to the computer system. So when the reader reads line by line, it is going to convert all these symbols into the computer understandable language, and it is going to process according to that. So that was the first phase of this automatic machines coming into picture by making use of programmable instructions, right? So this was over a very long time, right? And of course, still in some industries, they still use this very rarely, who have not updated it, right? And yes, so here the next thing is that after NC system that we have the control unit. So in control unit is nothing but it's got all this arithmetic logic unit, the processing, the central processing unit. It's got the arithmetic logic unit, right? And then the control units, the memory unit, right? For which the set of instructions is going to be received from the tape if it is an NC machine, or if it's a CNC machine, it is going to read the program fed through the system. Okay, right. Okay, so this is going to do the read the instructions line by line, okay, and convert it into useful signals, and that is going to be the output of this, right? Okay. So from the output of this control unit, the signals are going to go to the electromechanical devices, okay, which can be a stepper motor or anything else, sensors and so many other things, accordingly which these are going to perform the required actions, right? So if a set of instruction is going to be received that the motor has to run for 300 RPM, okay, yes, such type of signals are going to be received, and accordingly the electromechanical device is going to do those actions. Yeah. So yes, in the control unit, as we all know, just like a computer system, there is going to be electronics, that is the hardware, the reader, to interpret the program instructions and convert it into mechanical actions. That is, the output signals has to be given out by the control unit to the electromechanical devices. So yes, so previously if it's an NC machine, they make use of a tape reader. So tape is going to be fed to the tape reader, and it is going to read the data. Okay, just like a fax machine for our simple understanding, we can say. So from this, the data that it has to read is going to be stored in a buffer unit, just a small memory unit, and then it is going to go to the control unit. It is going to process it, right? And suitable signal outputs from the control unit is going to be given out, and that is going to be received by the machine tool, and it is going to perform the sequence of operations, right? Yes. Okay. So the next thing is the machine tool. So in the machine tool, for an NC machine, it has to have the suitable electromechanical devices, as I just mentioned, is about the stepper motors, sensors, data storage, right? And all those things are required. So that is going to be the final component over here, which is going to control the machining process, right? So this is going to be there. This actions are going to be there based on the program or the set of instructions that is being fed as the input. Yeah. So here it has to, if it's a lathe machine, it has to control the movement of the work table, then the spindle, the tool, and so many other things. So each one of this data has to be received by the machine tool, and it has to perform that required operations in a sequential manner. Okay. So yes, now coming to the extension of NC machine. Okay, so NC was the starting, the first step of the automatic machines coming into existence. Now that has been improved, where what is going to happen if we have a machine? Okay, if you're going to have a machine, okay, to this machine, what was there previously in an NC machine, there has to be a separate system, and for which there should be a tape reader to which a tape is going to be fed, and that data is going to be read by the system, and then it is going to control the machine, right? The advanced thing is that one of them is the computer numerical control, that is the CNC machines. So instead of all this, instead of tape reader and so many other things, for every machine there will be a computer attached, having a display monitor and a keyboard, right? So all the program and other things can be fed into that system there itself, and that is going to directly convert into all the required output signals, and it is going to run the machine. So that is all about a computer numerical machine, which is also called as a CNC machine. Okay, this is what many of them uses nowadays in the industries. The next advanced stage of this is the direct numerical control machine, something called as the DNC. So these are also the advanced forms of machines. Say for example, if we have machine 1, 2, 3, 4, 5, right, 6, all of these machines will have a storage system, but each one of them will not have a separate computer attached to it. They will be connected to a common computer, right? And all the programs will be stored in this computer itself, the centralized computer. Now, in machine 1, I can extract or import program number 10. Then simultaneously on machine number 4, I can import program number 5, which is going to do different set of operation, which is going to manufacture different part. Machine number 1 will manufacture different part. So simultaneously, whichever program I need, okay, I can call all these programs from the centralized computer system, so that one computer is going to take care of the so many machines, and all of these machines are going to can perform different operations, different parts that can be created, right? So this is about the direct numerical control methods. Then the advance is the adaptive controls, and then leading to the industrial robotics. There are certain situations where we cannot have dangerous, harmful, hazardous environments are there, where with the advancement we can make use of the robots to perform the required actions, right? So say for example in nuclear power plants, for some of the highly hazardous places, robots can be used, right? Robots can be used. And similarly, when it comes to say for example the paint shop in a automotive company, okay, where they have to do the spray painting, right? And it's going to be painted, and a human being inhaling that paint for a long duration is really harmful, right? It's going to create a hazard, especially in his health, right? So such situations we can make use of robots. Okay, so yes, so yes, this is what I just mentioned just now, a computer numerical control, right? It's also going to have a numerical control, which is a program that can be written by making use of numbers, symbols, right? And directly fed onto the machine itself. So there are CNC machines having 3-axis machine, 5-axis machine, 7-axis and all, like, which can perform the CNC lathe machine, CNC milling machine, right? CNC grinding machines are there, right? So like this, machines are available, right, for which they are all controlled by the computer. Yeah, right. So the thing is that they are a little bit expensive when compared to the normal lathe machines, that is manually operated lathe machines. But the need for this is that it has got high repeatability, good precision, right? Surface finishes are good, and dimensional tolerances are the same almost, not with much variations, right? And the production is going to be faster. More number of products can be manufactured in a less number of time. So these are all some of the needs and the advantages for why we have to go in for CNC machines. Okay, right. So yes, in a CNC machine is nothing but an NC system, utilizes a dedicated and stored program computer to perform all the NC functions, right? So a CNC system will have a mini computer attached to it and a controller unit. Okay. Yes. Yes. So this is a schematic diagram of all the about the CNC system, right? So what is going to be there is that first we have to give the input in the form of a program to a machine control unit, nothing but for the MCU, that is the computer system, which is going to store the data, process the data, right? And that is going to, that we can see it on the display, what are the program that we are going to type or input, and what are the other functions. After the data that has been fed is going to be the data that is going to be fed is processed, and the output signals are going to go to the required lines to drive those particular systems. So it can be a stepper motor, right, to turn the spindle, to move the tool, and so many other things, to move the table. Right? So that is going to be there in the driving system, which is going to receive the signals and perform the required operations. So thereby on the machine, the table is going to move, or the chuck is going to rotate. It's a lathe machine, the spindle is going to rotate, tool is going to move, right? And how much has this tool or table or these things have been moved? Has it moved exactly by 5 mm as per the program that is being given or not? So we need a feedback device for that, which makes use of sensors and other units. Okay, so that signal is going to go back to the control unit, and that is going to trigger the control unit and make the required corrections and perform the operation. So it's going to be like a loop. So there's an input and the operation has been performed, and there's going to be a check whether the operation performed is correct to the required extent. If not, an error signal is going to be sent, and the rectification output signal is going to be received, and the functions are going to be completed, right? All right. So yes, input devices, just like a computer system, we have like uh, a keyboard. We can make use of programs that is written on other systems by making use of the software, and feed it by making use of a floppy disk or a CD or a pen drive, and so many other things, right? So yes, so the machine control unit is going to be a highly accurate system that allows the machining of the to get the end products, right? Okay. So yes, so the machine control unit, it's going to have it's nothing but the heart of the entire system, where it's going to house the logical units, data processing control units, right? And each one of them are going to do their respective jobs, okay, as well as receive the feedback signals also and make the corrective action, right? And that is going to be the final output signal that is going to be sent to the uh, electromechanical devices. So the driving system, okay, which is generally the electromechanical devices, okay, and that they are going to perform the operations as per the instructions received, okay, in the form of electrical signals, right? So as I just said, several control motors, right, for rotational which determines the movement of the cutting spindle, so many other things. So feedback device, okay, so there is a need for the relay of the feedback for various processing during and after every process that has been completed, okay, which includes transducers, okay, sensors, scales, encoders, all those. So now coming to this, is the next one is about the open loop and closed loop system. In an open loop system, what is going to happen is that we are going to have an input program, then that program is going to be processed by the control unit. Suitable signals are going to be given out, and that is going to be received by the uh, driving system, and the machine tool is going to perform the operation. But how much has it really moved? The table has really moved. Has the tool really moved to the required distance in the required direction will not be known because there is no feedback for it. Considering the feedback system of what are the actions that has been taking place with respect to at what speed it is moving, where is it actually located, with that is mentioning it in the form of coordinates, all this data will be fetched back and the errors will be sorted out and corrective measures or actions will be taken and performed. So then it is going to be a closed loop system. So here we have a schematic diagram for a open loop system. Programs written and solved to the controller systems, and from there it is going to go to the machine. There's no creating a loop. It's just an open loop. It's just in unidirectional method. There's no closing at all. There's no returning back. So what is going to happen at the motor? How many rotations has it turned really, right? As it rotated at the required speed, that data will not be known in a open loop system. So next is a closed loop system, where the only difference is that with all these previous steps, there is going to be a feedback to the controller. So if the signal is 300 RPM, so it will check whether it is rotating at 300 RPM. Otherwise, it is going to give an error that there is some shortage, or it has been, or if it is on the other side, if it is rotating at a higher speed, corrective measures are going to be done in the controller, and the next signal is going to be given to the motor in the corrective manner. So advantages of CNC: highly flexible, repeatability, reduced indirect costs, right? So like labor, then maintenance, other things, okay, and increased productivity because we can manufacture n number of pieces at the same speed for 24/7. Consistent quality, because the tool is always going to move at the required speed only. Chuck is going to rotate at the required speed only for every part. So there will not be much variations at all. Reliable operations, because once the program is checked and a trial run is made and the product is being checked, then further on, usually it will be a reliable operation without much defects or something going wrong during the operation. So reduce non-productive time, that is like there is some kind of hindrances that has been caused where after some time even the human beings will become tired, and thereby the production will come down after 4 or 5 hours, right? So that is things will be avoided over here. So higher accuracy, so we can give precise movements of the tool because they are all electromechanically controlled by making use of stepper motors and other devices. So accuracy is good when compared to manual operation, right? And automatic material handling can also be done where material can be loaded onto the machine automatically, and which can save time, right? Some of the disadvantages is that the machines are costlier when compared to manually operated machines. Requires skilled operators. So a person should have the knowledge of programming and also knowledge of the machining operations, that how much should it be carried, what type of tool should be used, and so many other data. Right? So computer knowledge is required because they have to program it. Maintenance is difficult. So once when it comes to maintenance, it is the components, the devices are quite costlier. So maintaining this is makes it difficult, and it's going to be a costlier when compared to maintenance of manual machines. So yes, now coming to the classification of machining centers. Okay, we can go in for vertical or horizontal or universal machining centers. Okay, so yes, so let me show these details. Now let's see the machine itself. Just a second. So yes, so now you can see here is a CNC machine. Here we have a computer control with keyboards and a screen and all other switches and buttons to control the machine, right? So program can be directly fed, checked, the display, all those things is controlled. So through this, the signals are going to be received, and this is a CNC lathe machine. Okay, and here we can see the chuck on which the workpiece will be loaded. Okay, and here we have the tool post which is going to carry the tool, and the machining operation is going to be performed according to the program. So here we have another thing is called as the ATC, automatic tool changer. Okay, so it is going to have n number of tools. So as we have seen in lathe operation, single point cutting tool, knurling tool is different, right? And so many other things. So according to the instructions, the tool is going to be mounted. Tool is going to be mounted, and the machining operation is going to be performed. So we'll stop here for today.